This is the first of a series of video lectures, and this is the beginning of chapter 1. And as you can see, we have 9 topics for chapter 1: standard notation, addition and subtraction of natural numbers, and multiplication and division, and rounding and estimating order, solving equations, applications and problem solving, and then something about exponential notation and order of operations. So the first section, 1.1, is on standard notation. In section 1.1 we have 3 learning objectives. One is the giving meaning to digits in standard notation. Then we convert from standard notation to expanded notation, and then convert between standard notation and word names. Now, the reason we study mathematics is to be able to solve problems. So in this section we study how numbers are named. We begin with the concept of place value. When you look at a number like this, you notice that the 1 appears twice, and so does the number 2 and the number 3. But you also know from past experience that where they are, the 3 here and the 3 there, has different meaning. And so we talk about digits, which is a number 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, that names a place value location. So for large numbers, digits are separated by commas into groups of 3 called periods. Like here we have 2 commas and 2 groups of 3s. They're called periods, and each period has a name: ones, thousands, millions, billions, and trillions, and beyond. So they gave an example of people attending a show, a Broadway musical, and so this number appeared in there. So we use a place value chart, and it looks like this. So here are the digits. And here we have periods of ones, thousands, millions, billions, and trillions. And subdivided, we have the ones, the tens, and the hundreds. And here again we have the ones, the tens, and the hundreds, and so on for each of these periods. So when you look at the number we discussed at the very beginning here, we can say that's 11,362,732 ones. We typically don't spell it out and say, well, we do say 11 millions, but then we typically say 362,732. We don't necessarily use the word ones, but officially that's what it would be. And as a little exercise, how this can work, let's look at these questions here. What does the digit 2 mean in each number? Well, the number 2 shows up here, and so there would be 2 10,000s, because we are in the thousands here, and that's 2 10,000s. So for number 1, we write down 2 10,000s. And then for number 2, we have the 2 in this position here, so we have 200,000s. 200,000s. And here we look at the 2 here, and we see it's in the millions now. And so for number 3, the 2 would be 2 millions. And here for number 4, the 2 would be in the 10 millions. So for number 4, 2 10 millions. And here we have 2 tens for number 5, 2 tens, And here we have, for number 6, we have 2 hundredths. It is actually pretty simple, but you may want to rethink this here and have clarity about what the digit 2 means in each number. Okay. So here's another example. Government payroll. In 2015, the total payroll for all full-time federal employees in the United States was 19,369,134,421. What digit names the number of 10 billions? Well, here's 19 billion, so that's the 1 and that's a 10, so it would be the 1. This one here names the 10 billions. Again, you can look at the chart for the different periods, and then you find that the billions follow the millions, and the ones and the tens and the hundreds. And since we are at 19, it would be the tens. 10 billions would be the 1. So here we have the number in standard notation, 2,718 miles, the length of the Congo River in Africa. And writing in expanded notation means we have 2,000s. I'm going to write it over here because there's not enough space. So 2,000s. And 700s. 700s. And 1/10 plus 1/10, 1, and 8 ones, the last one, 8 ones. So that's what it means writing a number in expanded notation. Or here, we look at another number, 254,427. The number of families in Central and Eastern Europe assisted by HEFA International in 2016. To write that in expanded notation would be 200,000, 200,000, 100,000, 5 10,000s, plus 4,000s, and then we have 400s, plus 400s, and we have 2 20s, 2 10s rather, 2 10s, and we have 7 ones. And for number 10, 1,670 feet, the height of the Taipei 101 Tower in Taiwan. So we have 1,000 plus 600 plus 7/10 and we can leave it at that, or we can also write plus 0 ones. This part is not necessary, but just for completeness sake we can write it out with the last digit here. And for number 11 we have 100,000, 100,000, and 0, 10,000. So here we have to write the 0, 10,000 and 4,000. Plus 0, 100, and 9 tens, and 4 ones. So these are some examples of writing numbers that are given to us in standard notation, in expanded notation. Write a word name. Well, it would be 200, 204. Or for number 16, the number of state parks in the United States, that would be 10,000. 335, 336 rather, 336. So notice that we write this with a hyphen. Or in the guided solution, again, there's not enough space to really write the words. So we're just going to write this as 1,879,204. So 1,000,000 879 879 9,000 204. So we can leave the out. that end out 204. And here we have the world population in 2017. So it'd be ones, thousands, million, billion. So it'd be 7 billion 900 89 oops. So correction, 7,401,000,000 401 million 989,000 718. And the next exercise is the reverse. To write in standard notation 213,105,329. So that's 213,105,329. 329. And this concludes section 1.1.